and that's fine. I want to spend the last 5 or so minutes at the end of today talking a little bit more about the test and how it's going to work. And I'm going to change the homework in the ratio test. And because we won't have enough time for me to do everything that I want to do well. So what I'm going to do is essentially break this ratio test section into 2 sections. And the first one's going to be called part 1, and that's going to be due on Sunday, and those questions will be in the test, and they are just essentially the ratio test. And then after the test, when you come back on Wednesday, we'll focus on the rest of that section, which means it will be focusing on the nth root test and absolute convergence. So if you see anything with the nth root test or absolute convergence, it won't be there in about an hour and a half from now. Those questions will have disappeared. So if you want to just hold off a little while before you start looking at doing those homework questions, it would save yourself doing a question that disappears, right? So that's kind of how that's going to work. And it's fine, you know. These things are always judgment calls about how long they're going to take. Right, here's a guy. En is essentially this guy. En plus 1 is essentially this guy. The ratio test is that you find the limit as n tends to infinity of an plus 1 over an, and it's going to equal something. Let's suppose I do this question and the answer ends up being 42. Right? Suppose the limit of this is 42. According to the ratio test, what does that tell me about this series? If the limit was the number 42.
It diverges.
Right. Suppose it was a half. What would that tell me?
Converge.
Right. Suppose it was 1, and you hate it when it happens, but suppose it was 1.
Inconclusive.
Inconclusive, right? And that's an answer, right? It just means we don't know yet, right? It might be 1, it might be the other. You'll better find another test. So I'm going to skip a line here. En plus 1 is this guy. I'm meant to divide by an. Can I skip a line and just turn an upside down? Because if I do that, doesn't it save me having to write big ugly fraction over big ugly fraction and then convert it into this? And I don't think that's too big a leap for most people to be okay with. You okay with that? Skip the line and just turn upside down right away. Okay. So now we're into, oh, did you notice I also took out the absolute values, which are technically in the formula right now? And the reason I'm allowed to do that is, aren't all these things positive, so the absolute value isn't important. My next question, I'm going to show you one where the absolute value thing becomes a little bit more important. Right, time to start fixing and killing and doing all sorts of stuff. If you do enough of these questions, this becomes much quicker. Right, let's focus on this guy and this guy. Would you agree that they cancel out, but something's left over, isn't it? What is left over and where does it go?
104 in the denominator.
Agreed. I'll agree on that. 104 on the bottom, denominator. Now, n plus 1 factorial and n factorial. Once you get good at these, you can actually tell the answer. Does anybody actually know what the answer is going to be before I do it the long way to show you what the answer, how I got that answer?
N plus 1.
Right. Are you getting used to the factorials and the way they cancel each other out? So it does become quicker the more you do them. But not everybody's at that point yet. So n plus 1 factorial would be all the numbers 1, 2, 3 up to n plus 1. And n factorial would be all the numbers up to n. And then you realize that if you go 1 before n plus 1, you get n. And there's all the carnage. And you see it's on the top. Right, make this guy all go infinite. Not the biggest problem in the world. Would you agree that by brute force, the answer is infinity? Agreed? So what are we looking at here is divergence. Remember, the limit just needs to be bigger than 1. Would you agree infinity is pretty big than 1? Right. So, conclusion, divergent. In these questions, you're not being asked to find out what it converges to. You know, like sometimes give me the answer to 4 decimal places. Nah. Once you say it's divergent, end of the story, right? Move on to the next question. Okay, let's choose a question then that has some negatives in it that might help. Oh God, they're always hard to find until you're looking for one. I can always make one up if I can't find one. I just needed to look. This is my version of question 7. So it's going to be -1 to the n, 4 to the n, 3 to the n, n squared. Now in this question, an is that guy. And an plus 1 is going to be that guy. Eventually, I'm going to stop writing that line. Would you agree that eventually you know what they're going to be, right? So you can save a little bit of work with that as well. So it's going to be the limit as n tends to infinity of the absolute value of this guy over this guy, which is going to be the limit as n tends to infinity of this fella and the other guy turned upside down. And I forgot about the -1 guy. There we go. Right, here's something that's kind of helpful. You might be getting, oh God, what am I going to do with all these various negatives? Can I tell you right now, I don't care what the power of each of these -1s are, just kill them off. And the reason you can kill them off is because if you take the absolute value of -1, won't the answer just be 1, regardless of what power of -1 is being used? So the absolute values basically just take care of these guys. Now, you probably don't need this line, but I'm going to put it in now. Very often, this line disappears, and that's the next line of working. Can you imagine just doing the negatives go away, write down what's left, right? We'll try to reduce your workload by skipping things that you could probably do in your head. Right, time to start doing some killing. Things cancelling with things. Right. That fella and that fella, would you agree that they cancel out and 4 is left on the top? This fella and this fella, and they also cancel, doesn't that leave 3 on the bottom? Right now, I'm just going to leave the n squared and the n plus 1 squared, because it's sometimes a good idea just to leave them alone for a minute while you do the other cancelling. we're almost done. I want to find the limit of that ugly fraction as n tends to infinity. Couldn't I do L'Hopital on it? Couldn't I do divide top and bottom by n squared? I'm going to get the same answer. If you do enough of these, you kind of know what the answer is going to be. Anybody want to have an inspired guess at what the answer to this would be?
4/3.
Yeah. Have we done enough of these polynomials over polynomials to just get a feel for, yeah, that's going to be 4/3, that's going to be 0, or that's going to be infinity? Isn't that the typical kind of combinations you get? Now, this number is bigger than 1. Pretty obviously, right? 4/3 is bigger than 1. Conclusion. What can we say about that series?
Diverge.
Diverges. Now I'm looking at some of these questions and the homework questions. A few at the beginning get you to write down stuff, but after a while, you move on to the later ones. You basically tell me what is going on. Okay, so are we comfortable with this ratio test question? Is it becoming a bit more of a process and not as scary as it might be? Okay, that's a good sign. So I'm now going to, well, let me show you what I'm looking at so you can get an idea of what I'm talking about. Here is question 17 and the homework. They've introduced their own words, but I like it that they put in brackets my words, so we're agreeing. Here is the ratio, here is the guy. You do the ratio test. If the answer is convergent, there's the only thing you do in WebAssign is say that. If the answer is divergent, you say that. If the limit equals 1, inconclusive. Can you see that's just a very concise question now, right? You got a guy, what's he doing? Is that series going to converge, diverge, or is it inconclusive? And you can see there's quite a few of those guys. Okay, let's return. And I want to tell you some magic. This is magic because I'm telling you the answer and you're going to trust me, right? I'll make no attempt to prove it. It is doable, it is provable, but I'm not going to do it. What do you think the limit as n tends to infinity of n to the power of 1 over n is? Any gut feelings for what it is?
1.
Is it 1?
It is 1, okay. So that's magic. If you ever get a ratio test or an nth root test, and part of the problem is that's one of the pieces that you need to know what its limit is, it's 1. That's what it is. Now, how about this piece of magic? Now, unless someone has told you, I'd be amazed if you could guess that one. Any guesses?
Infinity?
It's possible. That's not the right answer, but I can understand why it could be. You know, that's
1.
getting really big. 1 is a very common choice. This is the one you won't expect. Right. I don't think you would have thought that as the answer. E to the power of AB. Okay. let's not make that magic. Let me just prove that to you. So I'm going to call this guy I. I'm going to call it I because I like the letter. Now, if I take the natural log of I, then I take the natural log of this fella. Agree? And this fella becomes Bn times the natural log of 1 plus A over n. And then I'm going to call it B, natural log of 1 plus A over n. And instead of that n, I'm going to put it on the bottom. So the natural log of I is this weird expression. You with me so far? You don't know why I'm doing this, but you're okay. It's true. So far, so good. Right, now, let's find the limit as n tends to infinity of this ugly guy. There is only one method that has got even a vague chance of winning here. What technique will I use to evaluate this fella?
Well, hospital.
Yeah, it's the only guy in town that's even got a chance. Now, the bottom, you trust me, is that guy. We just say, yeah, derivative of that is that, right? This fella is just B. If you differentiate a log, you get 1 over the guy. Oops. 1 over 1 plus A over n times the derivative of 1 plus A over n. And if you differentiate A over n, you get negative A over n squared. Now let me write that guy again. You get B times 1 over 1 plus A over n times the derivative negative A over n squared. And on the bottom, you've got a negative 1 over n squared, and we're still trying to find the limit as n tends to infinity. Now, normally when you do L'Hopital, don't things get nicer? And this one doesn't really look like it's working out, but it is. So, how shall I look at it? Two ways of looking at this. This is one way. I'm going to go this road. Isn't dividing by a fraction the same thing as multiplying by its reciprocal? Those guys cancel out, the negatives cancel out, and I am left with AB 1 over 1 plus A to the n. So that ugly fraction ends up being this guy. Okay, let's brute force it. What's going to happen when n goes infinity? What's A over infinity going to get you? A over infinity. What's it going to get? 0. So won't this just get you AB? Agreed? Now, if you've forgotten who this guy was, the natural log of I was this guy. Does it not make I e to the AB? Now, why do you need to know that guy? Well, you need to know that guy because when you do the nth root test, guys like that happen. Now, I know we're not on the nth root test, but I want those two guys out the way so that when we do on Wednesday the nth root test, we can start using that result. Okay, now let's return to ratio tests. Let's do some versions. How about this guy? Why did I change that n equals 1 to n equals 2? Because it doesn't seem to be
If it
that
was
relevant.
1, then it would be make it 0.
Yeah, and we don't want that, right? So some series start at 3 and 2 for that reason. Doesn't change one darn thing. It's still the ratio test. It's still going to converge or diverge or whatever. Let's see what this fella looks like. Well, it's going to be the limit as n tends to infinity. an plus 1 is going to be that guy over an, which is just this guy upside down. The 2's cancel, and everything's positive, so I can forget about those absolute values. Now we need to figure out what the limit of this fella is. There's only one rule that's going to work this time, isn't it, L'Hopital? So it's going to be the limit as it tends to infinity. Excuse me. We just have to get used to really weird algebra. If you have a fraction over a fraction, can't you take the top and multiply by the reciprocal of the bottom? Right, so 1 over n divided by that gets you this. Uh-oh. What's the limit of that going to be? I can use L'Hopital or just divide top and bottom by n, or I've done so many we now just know. What's the limit of that?
Diverges.
No, what number is the limit to that?
1.
1.
Yeah.
If the limit is 1, what do we know about this series?
It's inconclusive.
Yeah. So they're inconclusive. There's a situation where the ratio test fails on us, right? It doesn't tell us anything. Do you know that that guy diverges? Not because of the ratio test. Any ideas why I know that guy diverges?
The
If
top
I
will always
use,
be slightly bigger than the bottom, so it'll always keep going.
so again, Arvin, I missed the first part. I interrupted you, sorry.
As the top is always going to be bigger than the bottom, so it'll just keep going up and up and up.
Ah, well, for the beginning it is, but you know the log of 1,000,000,000 ends up being bigger than 2, so eventually it wins. That was an interesting thought. No, the reason why I know that diverges is if I do a limit comparison test with 1 over n, it would prove it to me. Those numbers are bigger than what 1 over n would be at the same place. So if you're bigger than something that diverges, you diverge. When you write it that way, it's called a comparison test. Okay, let's try this fella. Fact. Go for it. You got 2 minutes. You figure out if that converges or not using the ratio test, and then we'll do it together. This one is like 17b if you're interested. I hope as you go through these, you just get quicker. You just, oh yeah, this goes here, that cancels with that. This is what we get. Hope that's happening. Okay, we'll call it time. an plus 1 over an. Here's an plus 1. Turn the other guy upside down. These cancel, and there's a 3 left on the bottom. And the top, I believe, ends up being that guy, and the limit ends up being 1/3. Eventually, right? There's some, well, there's quite a few skip lines there, which means this converges. Oops. By the ratio test. Without doing any extra work, what do you think this series does?
Converges.
Won't this end up looking exactly like that once you take the absolute value of -1s out of the way? So have you noticed then that if you do an alternating series of a convergent series, won't it automatically converge? And if you take an alternating series of a divergent series, won't it automatically diverge? Don't know if that's helpful, but it's interesting. How about this one? If it turns it in. Getting a bit awkward. Normally, I don't write this line, but I'm going to make an exception for this question. Are you comfortable with this becomes that? And what I did is, do you notice 3/7 to the power of n can be written as 3 to the n over 7 to the n. And I pull the 7 to the n downstairs. Now, the reason why I suggest that you might want to do that is that isn't it just easier to deal with the ratio test when there's no awkward fractional powers floating around? Because if you're doing fractions of powers, you might start losing the place a little bit, especially when you're cancelling 3/7 is something in the top with 3/7 is something else in the bottom. But if you keep it clean like this, would you? The reason I would do it anyway is that it keeps it simpler. Right. So now that I've done that, let's do the ratio test. Oh, God, this is going to be dangerous, isn't it? Doesn't everything get killed with something and all over the place? A lot of damage getting happened here. Okay. E to the n plus 1 cancelling out with e to the n leaves me with a single e. 3 to the n plus 1 cancelling with 3 to the n leaves me with a single 3. I'm leaving the n alone, and I'm going to leave the n plus 1 alone. And lastly, the 7 to the n and the 7 to the n plus 1 gets me a 7. So on the next line, I'm just moving things around a little bit. 3ne on the top, and n plus 1 with a 7 at the front. And if I'd thought about it, I would have done this as well while I was doing it. Agreed? Now, I could divide top and bottom by n method. I could use L'Hopital. but that has a limit, right? It's a physical number I should be able to calculate. I think I'm going to do the divide top and bottom by n, just to be different. The top becomes 3e, and the bottom becomes 7 plus 7 over n, which when you make n infinite, that becomes 0. So you are left with that guy. Converges or diverges?
Diverges.
Correct. Why?
Because the 3e is greater than 7.
Correct. It's 1.6, 1.16. Can you see in that case, you might just want to grab your calculator? Because it's pretty close to being 1, right? And it might have been 0.98, you know, it could have happened, you know. If I just tweaked the 3 or 4, it might make a difference, right? Or if I took the 7 and made it an 8, it might make a difference. In fact, let me try that one. What about 3e over 8? Converging or diverging? Suppose it was 3e over 8.
I think it still slightly diverges.
Oh, well done. But look how slightly. Since I've started, I'm going to do one more. Suppose it was over 9, 3e over 9. I mean, that could happen.
That one converges.
Yeah. Exactly. So there's a kind of transition, isn't there, in this question? If you just change the 7 to an 8, it's still okay. But if you change the 7 to a 9, it becomes bad news, right? It becomes a diverger. And obviously, if you went 10, 11, 12, it would do whatever it was going to do. Maybe it's just me having an awkward day and I'm getting this wrong. I'm picking up a good vibe. Does this method, it's a process really and a method as well. Is it making sense that you feel comfortable about how it's going to happen, right? What we're going to do in the algebra of cancelling, because it's really about cancelling, isn't it? Because that's pretty much what happens all the time. So last question, then we can focus on what's going to happen in the test. This question is sigma n equals 1 to infinity 4 square root of n over 1 plus n squared. And that's going to be the limit as n tends to infinity of a ratio. I don't need the absolute value, but too late now. 4 square root of n plus 1s over 1 plus n plus 1 squared over a 1 plus n squared over the square root of n. And there should be a 4 somewhere. Yeah. Now, the only thing I can see that's obvious to cancel here is the 4s. So it's going to be the limit as n tends to infinity of 1 plus n squared, the square root of n plus 1, over 1 plus, darn it, can I just, there. Can you imagine me foiling that and add them together just so I got that mess? Over the square root of n. Now, this guy is extra ugly. If it was just square root over square root, like if that was the only thing that was left, wouldn't the answer be 1? I mean, you could do a L'Hopital on it. I wouldn't choose to do that. I would divide top and bottom by the square root of n, right? And you get the answer. Now, if it was just this guy, wouldn't the answer be 1? But you're sticking the two darn things together, and two things that have a limit of 1 sound like they should have an answer of 1. Agreed? But it might not be true, right? So let me tell you what is true. You are allowed to do this. What that says is, if you have a really ugly limit as n tends to infinity, and it's made up of various bits that don't play well together, you can take those bits and find their limits separately and then multiply the limits together. And it's the same answer as the big ugly guy that you didn't want to do. This is the big ugly guy we didn't want to do it. This is who he becomes. Now, if I use L'Hopital or divide top and bottom by n squared, would you agree that answer will be 1? Right. If I do this fella here and divide the top and bottom by square root of n, will you agree with me that it's also 1, like we said earlier? So the whole thing has a limit of 1, which is bad news for this guy because it means it's inconclusive. Now that trick of taking an ugly limit and breaking it into smaller pieces and finding the limits of the smaller pieces. Can you imagine that that might be a useful technique maybe in the future if you have really, really big, ugly limits to do with lots of different pieces all interfering with each other, right? So that's cool. So let's talk about, let's say hi first, get attendance in case I forget that. And while I'm getting myself set up with opening and closing things, where are we? That's not the one I want. That's the one I want. Nope. Is this the one I want? Nope. This is what I want. Right. Are you looking at WebAssign right now? Okay.
Yes.
Now, if you go to what would be your class, which is this one here, right? We'll pretend that we're in here, right? And I should be able to open students view with a bit of luck. I don't know where that is, but go away. This is kind of what you would see when you go into WebAssign, right? Your view is a little bit different from my view. Now, what you've got here, I've just picked the wrong class, haven't I? That shows you what my day is like. If you hold on for a second. Oops. There's our class. And there's student view. So that's what your class is going to look like. Do you see this section 11.6 right now? When you go back in about half an hour from now and you look at that, it's going to just say ratio test part 1. And that's only going to contain ratio test questions, right? And that's all you're going to see. And so that's what's going to be due on Sunday. So that's my first little thing to look at. Now, if we go, and I don't know where you are, but I hope you are looking at this guy. Maybe if I move this window over here. Right. Okay, this is what your class looks like right now, right? This is what your canvas looks like. This is not what it's going to look like in about an hour from now. But I haven't had time to get through it. You know how today I was saying I was hassled? I'm changing so many things, I haven't got round to doing yours. So I'm going to kind of give you an idea by showing you one of the classes that I have changed. Whoops, darn it, in space, I have to go to students view first, don't I? Go away. leave students view. Right. So this is very similar to what you will see. I wish I'd fixed it, but I just didn't have time. Can you see a thing that says test 1 information? It's a module. Yours will have the exact same link. What you do here is if you click on this, fingers crossed, there is a video on basically a piece of software called Adobe Scan. And the little video takes you through how you would load it up onto your phone. And you click on this little guy here, it takes you to the place where you would upload the thing. So you can use Adobe Scan. You can use anything you like as long as you can take pictures of your working and turn them into PDFs, right? So I'm just giving you that option as one of the options you could do. Now, you will have a fella here that will say, in your case, upload working from test, and it has to be due by, 12:30, right? It has to be due by 12:30. And when you click on this fella, there's a little video that essentially shows you how you would upload your working, right? So let me see if I can get into student view. Here we go. And upload working. And essentially you've got on your computer, wherever it is you've stored it, the PDF of all your working. You hit submit assignment. I don't know if you can see this thing, but it's annoying the heck out of me. Go away, that little window. There we go. Hit choose file. Pick your file. And then submit. That's as simple as that, right? So if you've had me before, nothing's changed. And so I get to see your working, and that's pretty much it. So you know your test is going to be about everything that we've done up until today. All the WebAssign homework questions will be locked out when the test, just before the test starts, just so you don't go back and find question just like it and use that. But you are allowed to use anything that you physically write down. So you might write down, for instance, the ratio test. You might even write down a couple of steps. This is what you do first. This is what you do second. If it's bigger than one, it diverges. Aide memoirs, right? Anything to help you. If it's physically written down, if it's on a PDF form, it's good to go. If it's on my website, it's good to go. Not allowed to contact Kathy in tutoring services or any other person and say, help me with this question, please, because that's cheating. You're not allowed to phone a friend. You're not allowed to ask your big brother. You're not allowed to use a Ouija board. I'm trying to go through all the possible things you might do to cheat. You're not allowed to communicate with anything, nor are you allowed to use software that does it for you. You could go to Mathematica and just type in a thing and it'll tell you if it converges or not. So I need to see working. If I give you a ratio test question, which I will, and you just tell me that it's convergent, if I don't see any working, I'm not going to give you any points, because you could just guess, and I don't see why you should get a lot of points for guessing. You could cheat, and you shouldn't get points for cheating. So if I don't see the process, i.e. you're working, I ain't giving you points. There's going to be a Zoom meeting, just like normal, for the hour of the class. And during that Zoom meeting, I'll see you, so I'll be able to tell that no one's working with you, and that's a way of keeping it fair. So everybody's on the same level playing field, right? And if I see you're working, as you all know, from the past, those who've taken me, doesn't your grade improve a lot more than what WebAssign said it was? Because WebAssign does not give partial credit. It just says 0 out of 20 because it's wrong. It doesn't care if it was just a tiny bit wrong or whatever. Right, any questions now?
Will the homework
What's the exact time of the test?
The test starts at our normal time, which is 11, and it will finish pretty much at 12. And you've got half an hour to upload it into Canvas. That's why it says 12:30 p.m. If that time doesn't suit you, if you just kind of don't feel comfortable, you talk to me in an email and I set up an individual different time slot for you and you'll do it then. Right. So hopefully it won't be too big an issue. There won't be that many questions because you can't really be expected to do too much in 50 minutes. So don't expect a lot of questions. Anything else I can think of? Somebody said something about homework, then I get cut off. What was that?
Yeah, will the homework be viewable on Monday after it's due?
It'll be viewable up until you start the test, and then like half an hour or an hour before that, I'll kill it.
Okay,
And
thank
then
you.
it'll return back to being seen again once the test is finished, because you might want to go back and look at it for revising for a final or something as well.
Got
So
it.
you can use it up to Monday's fine, right? You might get it really early on Tuesday, but don't bet on it. I might get up early on Tuesday and just close it then.
Will what will we have the test on? Like, will you have like the test on the screen share, or will there be like a file?
What the test will look like is a homework assignment in WebAssign. It'll just be called Test 1. And you'll go in and it'll ask you the questions are from WebAssign, so it'll look just like WebAssign homework questions. And it'll have an answer box, and you'll put the answer box in, because I find it helpful for you to do that as well. Right, do the work in, and if the answer's 42, stick 42 in the box, but keep the work in, that's the vital part. And then it's good because the test is a placeholder for your grade, because what I do is I look at your working and then I give you the grade, and that's what you'll see when you go into WebAssign. You can say, oh, I got 82% or 93%, and you can tell. So please fill in WebAssign, just with the answers. It doesn't take long. You'll have done the answer anyway, right? You've written it in paper and you're just a matter of transferring it into the box. If it can happen in the stress. Suppose the answer was 42, but you write 24 in WebAssign. Since I see you're working, you get 100%. The WebAssign's more of a placeholder for me. I check to make sure, because it also tells me which version of the question you're getting. If you don't know how this is working, you don't all get the same question. You know that they change numbers in WebAssign, but you also get pooled questions. So what I do there is I very often have 3 or 4 versions of the same kind of question. So even if you phoned Kathy up, who's totally honest and would say, go away, she couldn't really help you, because the chances are that her question isn't really yours. She could help you with hers, but that wouldn't help you with yours. So just another feature. I'm trying to, I know that you're all totally honest, but isn't it just a good idea to reduce the temptation of cheating by making it so hard to do that you're just not going to bother, right? You might as well just do what you can do the usual way. And that's fair. I think that is fair. Any more questions? I know I'm over your time, and I understand that. If you're good to go, you can just leave. If you don't mind, I'll keep this little bit of the video going for a little while. So once I finally put it online with Canvas, you can maybe watch it in case I said something and you'd forgotten what I'd said. So for those who are good to go, bye-bye. Those who've got more questions, keep asking till you have done what you want. Any more questions?
Professor,
Okay.
on the questions where it says determine whether the series is convergent or divergent, are we able to use our own discretion as to how we want to come up with that answer?
Interesting question. Your own discretion does not mean, I've seen that question before with a very small change and it was convergent, so I'm just going to call it convergent. I gotta see working. Now, in the working world, there could be more than one way of doing that, and that's fine. give you an example. Couldn't you do divide top and bottom by n to get the answer, or L'Hopital to get the answer? I don't
Right.
care. They're both
Right.
valid. So if that's what you're talking about, I'm on board with that, right?
That answers my question. Thank you.
Okay. Any other questions? I mean, as soon as you've got what you think's good, you can leave when you want. I don't want to keep you because it is your time. Any more questions?
How many questions are going to be on the test?
I couldn't tell you off the top of my head because I haven't done it yet, but God in Himmel, how many sections are in this chapter?
6.
or 5.
5 or 6? Which is it?
2,
5?
4. Oh, it's 6. Yeah.
It's 6. You won't get 6 questions. I just don't, you know, I don't know which one I'll drop, but I'm pretty sure I'll only do 5 because they take about 10 minutes each. Well, maybe they don't, but I want to give you enough time to get them done, right? So one of those sections probably will get dropped. What are we looking at? I'm going to have to give you a sequence because you only get one section. So you got to say a sequence question, right? What about, what's the other ones called? Divergence, something like that?
We have series test, integral test, comparison test, and alternating series test. And then we have the ratio test.
Okay, so one of those probably won't make it. I don't know which one yet. I'll figure it out when I do it. Since I pulled the questions, you may get a ratio test and Sam will get an alternating series test. So, you know, that can happen, right? The questions just get pulled anyway, so, but you'll get 5 because 5 at 10 minutes each sounds perfect to me. So when I do WebAssign, I'll make sure that I choose questions that the typical student takes 10 or less minutes to do. Any more questions?
Okay, so each question is going to ask you to do a specific type of test? Or can you decide?
No, the sequence, they may. If the question says use the ratio test, that's actually a help because it probably means that's the only test that would work.
Yeah.
Right? So you might want to use what they tell you. You might not get a test in sequences. Couldn't the sequence question be give me the next 5 numbers in this sequence? Or in a sequence it might say does this converge? So most of the questions will be test does this series converge or not? Right? Most of the questions tend to be that. I hope that answers your question. With the exception of sequences, most questions are tests. And if the test says use a particular test, then you should use that test. Any more questions?
I have kind of like just like an over question, but it'll take a long time, so I'll let everyone else go.
Okay, I'll hold on at the end and we can do your question. Anybody else got a question? Well, bye-bye to those then. That looks like the end of that. I think the people that are left are probably people who want help with homework and so on, so that's a different kind of situation. And so if that's what you want to stay about for, feel free. There we go. Oh, who is it that had a question? He's disappeared.
Oh, Samuel, do you want to go first?
Okay.
Sure, let me pull up the question.
So
Okay, so if I...
Oh, sorry.
Oh,
go ahead.
If I say it out loud, would you write it down?
Sure.
So sigma as n from n to n equals 1 to infinity of -1 to the n minus 1 power,
right,
times 10 e to the 1 over n power.
Ooh, I'm not sure how to write that. 10 on its own.
10 on its own times e.
Times e to the power of?
1 over n.
Okay, now I'm going to show you on the screen, and you'll say that's what I mean, and we'll move on from there if I did that right.
Yes,
Is that the guy? Okay.
so far.
So it's an alternating series test, I'm assuming, because when you see that, they tend to be alternating series.
Yes, and then all of that over n.
Oh, if that wasn't bad enough, right? Over n. Okay, so I need to prove that its limit is 0 and it's decreasing. And if I can prove those, it converges, right? And if the limit is not 0, then it diverges and the question's finished anyway, right? So I'm going to do the limit as n tends to infinity of 10 e to the 1 over n over n. What method do you think I'm going to use to find this limit?
Probably L'Hospital's rule.
Yeah, it's the only guy in town. You know, if it's not n cubed over n squared, isn't that pretty much L'Hopital every time that happens, right?
Yeah.
So if there's an e to the 1 over n, if there's some kind of, who cares, log n, yeah, things like that floating around, it's going to be L'Hopital. Well, that guy's easy. It's 1.
Yeah.
Differentiate e to the 1 over n, you get e to the 1 over n times the derivative of 1 over n. And what's the derivative of 1 over n?
Minus 1 over n squared.
Right. Now, I'm just going to rearrange that to that guy. Are you happy about this is the same as that?
Yeah.
Now I'm going to do brute force. Well, infinity squared is infinity. What's 1 over infinity going to get you?
0.
So what's e to the 0 going to get you?
1.
And 10 ones get you 10. And isn't 10 over infinity 0?